Hello guys, and welcome to Maths. This is one Maths class, e-learning phase 2. We celebrate you here, and then we want to show you some certain simplified and simple thing in maths. We are going to enjoy this in this phase 2. And remember to join this class with your full name and your video on so we can see what we are doing. And please remember to carry out the instruction as you can see on the screen. Send me your full name using the WhatsApp number you can see on the screen so that I can add you to a group where we can interact, and then you can send in your challenges. Okay, let's begin. Today we'll be looking at deductive proof 2, deductive proof 3. Sorry, now remember we have done deductive proof 1 where we talk about triangles and then the proof of the sum of angles with a triangle. We also look at deductive proof 2, where we talk about similar triangles, we talk about congruent triangles, and then we talk about equilateral and isosceles triangles. Here we put some basic theorems on isosceles triangles. If you missed any of previous classes, please we want you to go to the classroom and get the recorded video, or you can check our e-learning portal. Because it is important that you watch all the previous video before you can watch this. So today we'll be looking at properties of parallelogram and related quadrilaterals. So at the end of this lesson, you're going to look at the various properties of parallelogram and related quadrilaterals, and then we'll state and prove some basic theorem. Parallelogram on the same base and between the same parallel are equal in area. And then we're going to use these proof to solve some problems. So stay put and then enjoy this lesson. So the first thing we'll be looking at is quadrilateral. The term quadrilateral is a four-sided shape, just a four figure with four sides, just like you can see on the screen. The quadrilateral is a polygon with four sides. So any polygon with four sides is a quadrilateral. So can you give me some example of quadrilateral? Of course, you can see parallelogram is a quadrilateral, rectangle is a quadrilateral, square is a quadrilateral, kite is a quadrilateral, rhombus is a quadrilateral. So we're looking at parallelogram. You can see the structure here. Don't mind this diagram. You always indicate parallel lines on parallelograms. So a parallelogram is a plane shape bounded by parallel lines, as you can see in 2. What are the properties of a parallelogram? The opposite sides are parallel and equal in length. Please, Hans, I want you to be focused. Yes, thank you. Orizu, please, you are disturbing us. Thank you. All right. The opposite sides are parallel and equal in length for parallelogram. The opposite angles are also equal. Please take note of this. The diagonal bisect each other, but they are not equal in length in a parallelogram. Let me show you what that means. These are diagonals of a parallelogram. These are what we refer to as diagonal. You see this diagonal here, and then this is another diagonal. Oh, let me erase this. Okay, so this is diagonal. You see, they bisect each other, but they are not equal in length. Okay, so let's continue with the properties. Now we look at the square. Of course, every one of you know what is a square, even right from your primary school. So all four sides are equal. And for a sphere, it has four right angles. The sum of the angles in a square is 360 degrees. Now, let me ask you a question. What is the sum of the angles in a parallelogram? Gloria, can you help us out? Okay. What about you, Mobile 12? Can you tell us? Okay. Now take note of this. Every quadrilateral, be it a rectangle, be it a parallelogram, be it a rhombus, be it a kite, the sum of the angles in a quadrilateral is 360 degrees. So the sum of angles in a parallelogram is 360 degrees. Now the diagonal are equal in length and they bisect each other at right angles. Properties of a square. The opposite angles are parallel, the opposite sides are parallel, and the diagonal bisects the angles. The diagonal bisects the angle. Let me show you what this is talking about, so you can understand this much better. So this is the diagonal. It bisects this angle. This is the diagonal here, and then this is the diagonal here. For a square, you see, it bisects this angle. The diagonals bisect this angle. Bisect means divide into two equal parts. And the diagonal also divide each other. Here is equal to here, and they are also equal in length. So take note of this. This is what I'm trying to explain. Okay, so let's continue. For a rectangle, you can see that the rectangle on the screen, the properties, the opposite sides are equal and parallel for a rectangle. It has 4 right angles just as square. The diagonal are equal in length. The diagonal are also equal in length. So now let's talk about rhombus. You can see this is a rhombus. So the 4 sides are equal, you can see. The diagonal bisect each other, but they are not equal in length. Take note of that. They also bisect each other at right angle. Let's see. All the 4 sides are equal in length. The opposite sides are parallel and equal in length. Of course, when we say all the 4 sides are equal in length, you should know that the opposite sides are parallel and equal in length. The opposite angles are equal. Say yes, for every rhombus, the opposite angles are equal. What do I mean by opposite angle? Let me show you. This is what we mean by opposite angle. This angle, the angle here, is opposite to the angle here. So the diagonal bisects the angles. What we are trying to say is that you look at this diagonal, this divide this angle into 2 equal parts. The diagonal bisect each other at right angle, but are not equal in length. Yes, that's true. So this diagonal here, they bisect each other at right angle, but they are not equal in length. This is what I'm talking about. They bisect each other, they divide each other at right angle. You can see that here. But they are not, you can see that here, but they are not equal in length. Okay. So that is all about rhombus. So now let's look at kites. Now, as you can see on the screen, 2 pairs of adjacent sides are equal in length. You can see here is equal to here, and here is equal to here. One of the diagonals bisect the other, but they are not equal in length. Look at this diagonal bisects this diagonal. Divide it into 2 equal halves. The diagonal intersect at right angle. As you can see on the diagram here, it intersects at right angle. Only 1 pair of opposite sides are equal. Look at this. Here is equals to here, and then here is equal to here. So only 1 pair of opposite sides only one pair of opposite sides are equal. Trapezium, some can call it trapezoid. It has to do with how the American and the British call it. So you can call it trapezium, you can call it trapezoid. It has four sides that are not equal in length, as you can see in the diagram above. The diagonal are not equal in length. If you draw the diagonal of a trapezium, they are not equal in length. All the four angles are not equal, as you can see on the diagram there. All the four angles are not equal. Only one pair of opposite sides are parallel. As you can see, this side is parallel. This side is parallel to this side, even though I do not indicate parallelism. I want you to take note of this. Take note of this. Very important. Very, very important. Take note of this. Take note of this. What I want to do here. You see that? Take note of this. Squares, rectangles, and rhombus are special forms of parallelogram. Take note of it. Don't forget that. You don't have to forget that. Don't forget that. Okay, so let's move on. Theorem. Don't worry, I'm not going to bore you with the proof of the theorem. We'll just state it and then apply it. Remember, when I was talking about the properties of parallelograms, one of the properties is that the opposite sides are equal, but also the opposite angles are equal. Don't forget this, because we're going to apply this in the next problem, next slide. The opposite sides are equal, the opposite angles are equal. Please, can you say that after me? The opposite sides are equal and the opposite angles are equal. Can you say it again? In a parallelogram, the opposite sides are equal, the opposite angles are equal. Correct. Let's say it again. The opposite sides are equal, and the opposite angles are equal. That's enough. That's enough. That is enough. Now, let's apply this. Pick up your pen, everyone, and solve this problem. Find the angles of the diagram below. That means the angle Q, angle X, and the Y. Now, take note of something. Whenever we give you a problem in mathematics and you see letters, the way the letters are set is such a way that, according to the alphabetical order, Q should be solved first, then X before Y. Just take note of that. So I'm going to tell you what to do. Take note of this. Now, just follow my example and then you'll solve this problem. Because I'm not going to solve it, but I'll tell you what to do. In a parallelogram, the opposite angles are equal. It means, let me show you something. Just wait a minute. I'm going to show you something. So I will leave you to do the rest. Leave it to do the rest. So we say the opposite angles are equal. That means angle Q is equal to what? 60 degrees. And X is equal to what? Y. So automatically Q is 60. Now, let me ask you this question. Recall that we say that the sum of angles in a quadrilateral is what? Correct, 360 degrees. So to get X and Y, you are going to say Q plus X plus 60 plus Y equal to 360 degrees. So I want you to do that and then tell me your answer. Q is already 60. Q is already 60. Q is actually equal to that to 60. So, oh, don't mind this pen. So, if Q is 60, remember to do this. If Q is also 60, then say 60 plus 60 plus X plus Y should be equal to 360 degrees. Remember, X and Y are the same. X and Y are the same. So you are going to say 120, X and Y are equal. So you can say X plus Y. X plus X. So plus now to be 2X equal to 360 degrees. So I'm going to stop here. I want you to finish this up. When you get the value of X, you're getting the value of Y. So what is your answer? Just waiting. You can use this chat button. You can just tell us your answer. You just collect like terms and then divide both sides by 2. That's 360 minus 120. You will have 240. Right? Yes. You will have 240. Check. Math is so sweet, you know. Okay. So who is giving us an answer? 240 divided by 2. So X is equals to Y is equals to 120. Thank you very much. Let's continue. Now we are going to one of the important aspects of this lesson. This is parallelogram on the same base. Parallelogram on the same base. This is it. Please, I want you to draw this diagram. You know, I like to take water. So, on the screen is parallelogram on the same base and between the same parallel. We have parallelogram P, Q, RX on the same base, RX, and we have parallelogram X, Y, RX, still on the same base, RX. Please draw this diagram on your notes because there's something I want you to do. Just waiting. Okay, now look at this diagram carefully. Can you identify two triangles? Because we are going to prove this theorem. Can you identify two triangles? Okay, that's correct. We have two important triangles here. Triangles P, triangles PXR. That's, we have triangles PXR and what? QYX, correct. QYX. Now, take note of something. To prove this theorem, first of all, we need to show that these two triangles are congruent. Remember, we've done congruent before. We need to show that triangle PXR is equal to QYX. To do that, now I want you to follow me and do this. This place. Here. Here. This angle. This angle. Now, for this plate, this angle, I want you to put D1. Put D1. Why here? I want you to put D2. And in this place, I want you to put label it A1. Label it A1. While here, I want you to label it A2. Now, to prove congruency, we are going to show that two angles in triangle PXR is respectively equal to two angles in triangle QYX. And then we also show that corresponding sides of the two triangles are equal. Now, look at angle D. Look at angle D, this angle, and D1 and D2. What can you say about D1 and D2? As well as A1 and what? A2. Now, okay, reason. Okay, they are equal. Yes, they are equal. I need to know the condition of their equality. Okay, Gloria. Corresponding angle, you are correct. D1 and D2 are equal, corresponding angles. Similarly, A1 and A2 are equal, corresponding angles. Please look at side PI. Let me show you using side PI is equal to QS. Opposite side of what? Parallelogram. Remember, we say that opposite side of parallelogram are equal. Look at this. This side PR is equal to side QS in these different triangles. So automatically we say that the two triangles are equal. So let me show you the proof now in the next slide, step by step. Baby step proof. I call it baby step proof. Now let's go. First thing to do, like I told you in the first lesson, deductive proof 1, you must state the theorem. Parallelogram on the same base and between the same parallel lines are equal in area. Then the next thing is the diagram, which you can see on the screen. The next thing to say is to state what has been given based on the lettering of your diagram. Remember, we've done that before. Given parallelogram PQRX and XYRX on the same base RX and between the same parallel PY and RX. This is a parallel PY and RX. Next, what do we want to prove? According to the statement, parallelogram on the same base and between the same parallel lines are equal in area. So we want to prove that the area of PQRX is equal to the area of XYRX. So let's go. This is what I asked you to do by labeling the angle D1, D2, and sorry. Oh, this is a mistake. This is a mistake. It's A1 and A2. Don't forget that. So now let's start. To prove area of PQRX is equal to what? Area of XYRX. Next, proof. We need to show that triangle PXR and QYX are congruent. Look at it, PXR and QYX are congruent. First of all, angle D1 is equal to D2. What is the reason? Corresponding angles. This is a short form of corresponding angles. Similarly, angle A1 is equal to angle A2. The same reason, corresponding angles. Look at, don't mind this is a mistake. This is A1. Next is side PI is equal to QX. The reason is the opposite side of what? Parallelograms. Opposite side of parallelograms are always what? Equal. Opposite side of parallelogram are equal. If that is the case, two angles are respectively equal in the two triangles, and corresponding sides are equal, then we say that triangle PXR is congruent to triangle QYX. Our reason is angle, side. That's the principle of what? Congruency here. If that is the case, let me now show you something. The next step is very important. Now, I want you to look at the diagram. If that is the case, then we can say that the area of parallelogram P, Q, R, X minus triangle Q, Y, X will be the same as the area of X, Y, R, X minus triangle P, X, R. Let me show you that in the next move. Thus, area of PQRX minus triangle QYX should be equal to area of XYRX minus triangle PXR. Take a look at that. Now, if these two triangles are equal, QYX and XPXR are equal, which we have proven before, it means they can cancel each other out. Since triangle PXR is congruent to triangle QYX, the triangle cancel out. And if the triangle cancel out, then we are left with area of PQRX equal to area of XYRX, which is our proof, which is what we want to prove. So this is the end of our proof. So please, you can play this video over and over again to understand the various steps of this proof. Remember, you can send me your challenges or question to Mascora SS1 on WhatsApp group. Next thing we're going to do, we're going to apply this formula to solve problem. Let's go. Problem 1. In the figure below, A, B, C, D, and E, F, D, C are parallelograms. A, B, E, F is a straight line. If AF is equal to 11 centimeter and side BE is equal to 3 centimeter, find DC. Find DC. So let me show you. Let me show you what this is talking about. The question says BE is 3 centimeter. This is BE. This side is BE. That is 3 centimeter. 3 centimeter. And AF, let me show you AF. This from here to here is AF. This is AF. Now, AF is 11 centimeter. 11 centimeter. Don't mind my centimeter. The writing pen is somehow. Let's just manage it. Now, I'm just giving you the hint because I'm going to leave you to do it yourself. From our proof, we will see that EF is equal to DC. And DC is equal to AB. Because parallelogram A, B, DC is on the same base DC with parallelogram EF, DC. That means they have equal areas. And the question wants us to look for DC, this place, DC, DC. The question wants us to look for DC. So, start, give us the answer. I want everybody to get to work and give us the answer. We can look at giving you the hint on what to do. Yes, 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 yes. Okay, 4. Okay, okay, okay. Somebody said the answer is 4 centimeter. Okay, let's check because of our time. Let's check. From here to here is 11 centimeter and BE is 3 centimeter. So if I should remove, 3 from 11, I will have 8, right? That means EF and AB, they are 8 centimeter. Since they are equal, you see, AB is equals to EF and they are equal to DC. It means if I divide 8 into 2 equal parts, here I will have 4 centimeter. Here I will have 4 centimeter. Automatically, DC is also 4 centimeter. That's all. It's so simple, right? So simple. So the best, those people that say, those students who say it's 4 centimeter, they are very correct. So simple. I told you I'm going to teach you mathematics made simple. Now I'm going to show you how to prove this using step by step using mathematical statements. The same thing I'll show you using mathematical statement in the next slide. Let's go. Solution. Here is what you were given. AF is 11 centimeter, BE is 3 centimeter, and find DC. Because the AF is equals to AB plus BE plus what? EF. And BE, AF is equals to BC is equals to AB, like I show you in the diagram. BE is 3 centimeter, remember that, and AF is 11 centimeter. So if EF is equals to DC is equals to AB, we can remove EF and then put AB. You can see that here. BE is 3 centimeters, so we do our substitution. AB plus AB is 2AB. And then we collect like terms. That's 11 minus 3 and divide both sides by 2. When you do that, you have AB to be 4 centimeters and AB is equals to DC. So automatically DC is what? 4 centimeters. So this is the step by step using mathematical statements to prove this. So if you have a question, you can raise up your hand, you can indicate and ask your question. Next, it's your turn to try this. But I'm going to give you hints on what to do. You are to find DBC, angle DBC in this diagram. So let me give you the hint on what to do because we are doing mathematics made simple. Look at this. Remember the theorem of parallelogram, opposite sides are what? Equal. It means that this side is equal to the whole of this side. And you are asked to find the DBC. So you are asked to find this angle. Let me use double stroke for the angle. You are asked to find this angle. Yet. So what do? All you need to do, 110 degree plus this side is equals to what? 180 degree, angle on a straight line. Automatically this side is 70. It means angle ABC is also 70. It means the whole of this side is 70. Remember, this side is already 26. So if the whole of this is now 70 and this side is 26, to get the rest of this side is 70 minus 26. Simple. So please take up your pen and do that. I have given you a detailed explanation. Okay. The next problem is similar to what we have done. So take out time to find RX. take out time to find RS. Sorry, not RS. Find PY. PY. You might recall the same thing that we did. Sorry. The same thing that we did. Let me explain this homework first before we proceed. Recall that PQ is equal to side RX equal to side XY. And in the question, QX is given to be 2 centimeters. Just giving you the hint. So this is so simple to find PY. And RS is given to be 4 centimeters. 4 centimeters. So automatically you can solve this because I have done completely. Please take out time to do this. Then I have some assignment here for you, which is what still application. I know if you follow what we did in the first problem, and then what you do in your classwork, you can be able to solve this. And then question 2, in quadrilateral ABCD, the lines bisecting ABC and BCD, the line bisecting ABC, angle ABC and BCD meet at P. Prove that angle BAD plus ADC is equal to 2BPC. So please, here, this requires you to use all your skill in all the deductive proof 1, deductive proof 2, and deductive proof 3, the way we prove to reason. Draw the diagram and then prove this. Show me your skill that you've learned how to prove a problem in mathematics. And then if you are having challenge in doing this, please remember to refer to our group, Mascora, SS1, the SAT group. And then I will be guiding you and directing your thoughts right to answer this assignment correctly. Remember, this is assignment 4. Thank you for your time. Today we just look at deductive proof 3, properties of parallelogram and related quadrilateral. And then we look at the properties of the major quadrilaterals, and then we prove that the parallelogram on the same base and between the same parallel are equal in area, and then we apply this to solve some problem. Thank you very much for your time, and then I'd like to see you in the next class for another interesting edition of Mathematics Made Simple. Thank you very much. Goodbye. Have a nice time. Have a nice day. Remember to always stay safe.